Find the unit tangent vector and the unit normal vector to the spiral helix r of t equals 4t, 5 sine 2t, 5 cosine 2t at the point pi, 5, 0. So the unit tangent vector t of t is defined as r prime of t divided by the magnitude of r prime of t. So let's calculate r prime of t. That would be 4, and then 5 times the cosine of 2t times 2 by the chain rule, and negative 5 times the sine of 2t times 2. Again, the chain rule, and the derivative of cosine is negative sine. So this is 4, 10 cosine 2t, negative 10 sine 2t. And the magnitude of r prime of t is 4 squared plus 10 squared cosine squared 2t plus negative 10 squared sine squared 2t, quantity to the 1/2 power, the square root of the sum of the squares of the components. And since sine squared 2t plus cosine squared 2t is 1, this is 4 squared plus 10 squared to the 1/2. So this is the square root of 116, and 116 is 4 times 29, and the square root of 4 is 2. So this is the same as 2 times the square root of 29. So t of t, the unit tangent vector, is this vector here times 1 over this number here. So I can factor out a 2, and I get 1 over the square root of 29, and then 2, 5 cosine 2t, negative 5 sine 2t. So again, t prime of t is this vector divided by this number. We factor out a 2, the 2 will cancel, and we just get the square root of 29 on the bottom, and we get 2, 5, negative 5. Okay, so there's our unit tangent vector. At any point, eventually we'll go back and worry about this point, but first let's find the formula for the unit normal vector. So the unit normal vector, n of t, is equal to t prime of t divided by the magnitude of t prime of t. So t prime of t is 1 over the square root of 29 times times the vector 0, and then negative 10 sine of 2t, and then negative 10 cosine of 2t. So this is t prime, and the magnitude of this vector is 1 over the square root of 29, and the magnitude of this is just 10, because if we square these and add them up, we will get 10 squared times cosine squared plus sine squared, and those make 1. So we get 100, and the square root of 100 is 10. So this is 10 over the square root of 29. The square root of 29's cancel, and we get 1 over 10, and we can factor out a 10. So that cancels, and we just get 0, negative sine of 2t, cosine of 2t. So this is our normal vector here. Now the point was 5, the point was pi, 5, 0. Let's just look at that again. Pi, 5, 0. So where is that in the original on the original helix, what value of t does that correspond to? So if we set 4t equal to pi, and 5 sine 2t equal to 5, and 5 cosine 2t equal to 0, we should get the same value of t in every case. So let's figure out that value of t. 4t is supposed to be pi. Well, that tells us that t is pi over 4. And let's just double check that. If we plug in pi over 4 here, that would give us sine of pi over 2. The sine of pi over 2 is 1 times 5 is 5. And the cosine of pi over 2 is 0. So pi over 4 is our value for t. And so to finish off the problem, we would like to know t of pi over 4, and we would like to know n of pi over 4. So t of pi over 4 is 1 over the square root of 29 times 2, and then the cosine of pi over 2 is 0, so 0, and the sine of pi over 2 is 1, so this becomes negative 5. So again, we're plugging in pi over 4, and we have to double that. So we're taking the cosine and sine, not of pi over 4, but of pi over 2. And here, same thing, we're going to take the sine and cosine of, I think this should have been a negative, I did not copy a negative there, negative cosine 2t, negative. It's going to be a 0 in this answer, but still. We're going to plug in pi over 2, the sine, pi over 4, and the sine of pi over 2 is 1, so this is negative 1. So we have 0 comma negative 1, and this one's a 0 as well. So there's the normal vector. So the helix is going around, and at a certain point, the vector here is pointed in the opposite direction as the y-axis. Maybe the y-axis is this way, and this vector is parallel to the x and parallel to the xz plane. Actually, wait, it's parallel to the y-axis. It's parallel to the y-axis and in the opposite direction of the y-axis, as I drew it here. Parallel to the y-axis, perpendicular to the xz plane. Okay, there's our answers. T of pi over 4 is this unit vector, because this is a unit tangent vector, and this vector is the direction, going in the direction of the curve, and this vector is perpendicular to that tangent vector. It's called the normal vector. It's also a unit vector, and it points in the direction that the curve is bending. So the curve was bending this way, and so that's the direction. Because if you have a tangent vector here, a normal vector could be in either of those two directions. The unit normal vector always points in the direction that the curve is bending.